Okay, so factors. A factor, what I want you to think of it, y'all, is a number that divides evenly into another number. So if we just think about straightforward multiplication, 2 times 5 equals 10. But what that means is I can divide 10 by 2, and I can also divide 10 by 5, right? 10 divided by 2 is 5, 10 divided by 5 is 2. So because those two multiply to 10, I know I can divide those numbers both into 10. Therefore, they are called factors. So if you see that number on the test, if they say the word factor, they're trying to say a number that will divide evenly into some other number. And if you do have a number and you want to figure out what all the factors are, well, you can use like a little T diagram like this. That's very helpful. Because generally, the nice thing about the T diagram is that there are usually two factors that when people are trying to write all the factors of a number that they will miss. Can anybody tell me, without us doing this little diagram yet, what other numbers divide evenly into the number 10? Yeah, Debbie, 1 definitely divides into the number 10, so 1 would also be a factor. And Ash, Dion, very good. So 10 would also be a factor, right? And this is why like this little T diagram can help, because a lot of people forget about 1 and the number itself, which are always factors. So what you want to do is you always just want to start with 1 and the number itself. And then just kind of go up from there, testing out other numbers. Does 2 go into 10? Yeah, definitely. Does 3 go into 10? Nah. Does 4 go into 10? Nah. Does 5 go into 10? Yeah. But once you've kind of gone all the way around that circle, then you're done. You could say that's it. I don't have to test out 6. I don't have to test out 7, 8, or 9 because I've, already thought of the other side. Now, this is actually kind of controversial to me because I feel like on other standardized tests, they would not consider negatives to be factors. Debbie, very good. Very good. But on the GED, I want you just to be very careful. Make sure that they say like positive factors because I guess they are going to count negatives as factors. I feel like that is contrary to other tests. But like if I was like teaching my GRE people, I'd be like, nah, factors are not going to be negative. Multiples can definitely be negative on all tests, but I feel like factors aren't very often. Hello, Dakshash, how you doing? Let's do another one just for a little bit of practice. And let's do one of my favorite numbers, the number 24. Is anybody like an old timer like me and remember that show back in the early 2000s? Like Kiefer Sutherland? Man, that show ruled. It was called 24, Candida. It was literally called 24 Friends. No, that's the 90s. Okay, I'm talking about early 2000s. That show should have been called like Cliffhanger the Show. I remember like that show had like 5 cliffhangers like every single episode. It was awesome. Friends was good. Friends was good. Okay, so let's do it. Let's go through. Let's start with 1 and 24 because those are always factors. Now, y'all, 2. Does 2 go into 24? How many times does 2 go into 24? 12 times. Yup. How many times does 3 go into 24? 8 times. Yup. How many times does 4 go into 24? Yeah, 6 times. Y'all, does 5 go into 24? Nah. Nah. 5 does not go into 24. So we're done. At least with the positives, we're done because now we're back over at 6. All right. Debbie, you weren't even born. Yeah. Well, check it out. I'm sure it's streaming somewhere. I'm sure it's streaming somewhere. If you're looking for like something to binge, it is so bingeable. especially with those cliffhangers. You'll just spend an obscene amount of time watching that show. Okay, so now let's talk about the opposite side of this a little bit, which is multiples. So a multiple then is if you take your number and you multiply it by any other integer, right? So like some multiples of 24, well, we would have like 24 times 1 would just be 24. 24 times 2 would be like 48. 24 times 3 would be like 72. 24 times 4 would be 96. 24 times 5 would be 120, etc., etc., etc. These are called multiples because you're taking your original number and instead of finding smaller numbers that would divide into it, you're saying, well, let me take that and multiply it by any other number, and that gives you multiples. Okay. So y'all, everybody give me a Y in chat if that makes sense. What we mean by a multiple. Now, multiples can be negative as well, so you got to be careful of that. So I can multiply 24 by negative 24 and get, or I'm sorry, 20, negative 24 squared. No, by negative 1. 24 times negative 1 will give me negative 24. 24 times negative 2 would give me negative 48, etc., etc. So those also count as multiples. Then one final number that counts as a multiple, kind of sneaky. If I multiply 24 times 0, I get 0. And 0 is an integer. So believe it or not, y'all, 0 is considered a multiple of 24. This blew my mind when I first learned this. I'm like, really? 0 is a multiple of 24? But it is. 0 is a multiple of anything. Because you could take any number and multiply it by 0 and it turns into 0. I know, that's crazy, right? It's wild. But they can throw that at you as a trick. Now, one thing, well, because I don't know how to say your name at all, but I'm gonna say just Lou because I'm not sure if that's like your handle or your name. But because the definition of multiple is you take your number and you multiply it by any other integer. Oh, Autumn, right. And 0 is an integer. It's considered a whole number. So any number times 0 would give you 0, and that makes 0 a multiple of everything. Such trickery, Eddie. Such trickery. But notice 0 can never be a factor. Y'all, why not? Why can 0 never be a factor? Oh, ED. Okay, thank you. Yes, Brandon, you cannot divide by 0. You can't do it. I don't know if y'all know this, but if you ever successfully divide by 0, the entire universe gets sucked into a giant wormhole and we all cease to exist. Okay, so don't do it. Don't do it. It's bad. You can't do it. Yeah, I mean, that's one way to think of it. Like, mathematicians say it's undefined. It's just like undefined. It just kind of doesn't really mean anything to divide by nothing. Like, what do you mean divide by nothing? It just doesn't really mean anything. So that's why they say that. Try it, Debbie. Let me know. Well, I'll know if you succeed and the entire universe blinks out of existence. So I'll be when it happens. I'll be like, ah, Debbie, she did it. She did it. Okay, so a couple more things to talk about here with this show. So now that we kind of know what factor and multiple means, so one thing we can get asked at times is the greatest common factor. That would mean what's the biggest number that would divide into the same two numbers? And we can use a t-chart to do that. Like if we do a t-chart for both numbers, we will be able to find the biggest one that goes into both. Right? So like if we're doing 48 and 72, for example, we can do 48, 1, and 48. Now, I guess a difference between what they're doing, the way they did this animation, I should change this animation, but I would start 72 already, right? And go like, okay, let me do 1 and 72. All right. Now let's keep going with the bigger one because I want to stop as soon as I find a big one. What's the biggest one they're both going to have in common? So I'm going to be looking at like this column. So let's take 72. Let's keep breaking that down. Y'all, how many times does 2 go into 72? Yeah, and you can just put it into a calculator. It is going to go in 36 times. Like that. Okay, cool. Let's continue with 48. Well, actually, let's continue with 72. How many times does 3 go into 72? We got 24. Now I could keep going, but I'm looking at this. I'm looking at this and being like, y'all, how many times does 2 go into 48? Ah, yes, 24 times. And because, like, we can keep going and get the other factors now, but since this column is always the biggest, they don't share 48 between them, but they do share 24 between them. So we could just stop right here and say 24 is the biggest common factor. Everybody give me a Y in chat if that makes sense. Okay, good. And you could keep going and make all the other factors, but you're just kind of like wasting your time if you're doing that because we're just looking for the biggest one. We only care about the biggest one. So I like kind of doing both at the same time and just starting at 1 and then keeping going from there, but just kind of watching this column and going back and forth between them until I just find one that matches and then I stop. I'm like, I'm done. All right. Now, the opposite of this then is the least common multiple. So this is the smallest number that is a multiple of both. So this, we're doing the opposite, where like, remember when we were at 24 before and we kept just writing bigger and bigger numbers, 24 times 1, 24 times 2, 24 times 3, 24 times 4. That's what we would do here. Let's see which ones they're gonna make us do. Okay, they're gonna make us do 20 and 30. All right, well, let's just start doing multiples of 30. So the first one is always just times 1. Okay, so 30 times 1. Y'all, what's 30 times 2? It's gonna be 60. Now, we can keep going, but I might want to already kind of be thinking to myself, well, wait, hold up. Hold up. You know, you can keep going with this more and more if you want, but as soon as you like see one that you're like, is it? Is it? Just check it out. So we have 20 times 1. Y'all, what's 20 times 2? It's 40. What's 20 times 3? 60. And this is the smallest thing that they have in common. Of course, again, we could keep going. And, you know, they are going to match back up at 120. 120 is another common multiple. It would indeed be another common multiple, but it's not going to be the smallest common multiple, right? So we can just stop as soon as we get it. All right, good. So let's go ahead and do some problems here, y'all. And honestly, I think, well, let me show you one more thing. I wish they had given me one, Debbie, but they really haven't. But let me just give you another example. Well, maybe I'll try and see. I hate doing this. This is where like I'm gonna mess up because I actually do not have that big of a math brain. So when I try and come up with my own examples, I embarrass myself terribly. I'm gonna go ahead and try and come up with some examples for this. So let's say the number 75 and the number 42. And I want to find the least common multiple of both of these numbers. Okay. This looks a little bit more annoying. I guess it wouldn't be like that terrible necessarily. We can just start listing the multiples of 75, start listing the multiples of 42, and like see where we finally hit one that matches. Okay. Might take us a little while, I don't know. But here's what I'm going to do instead. I'm going to do something that like I named it. I didn't name it. That mathematicians call prime factoring. And so what do I mean by this? So another way of kind of thinking about breaking down a number instead of making like a T sort of thing for factors is to break down a number in like branches. Yes, Sarah, you've seen this before. So the idea here is I'm just going to think of any two numbers that I can think of that would multiply to 75. Right? And y'all yell out for me in the chat. Does anything jump out at you? Two numbers that would just multiply together to make 75. Yeah, 25 and what, Tyrese? Dakshash. D, awesome. Yup. So 3. So let's say 3 times 25. Okay. Now, we could do 5 and 15. We absolutely could. Yeah, 5 and 15. That would be perfect. Right? We could totally do that as well. But 3 and 25 we can do, and it will work out the same way either way. 3 we can't break down anymore. There's nothing else to break it into, but 25, y'all, we can break into what? Yeah, 5 and 5. Okay, cool. Let's do the same with 42. Yo, what can we break 42 down into? Any two numbers that would multiply to 42. We could do 3 and 14. We could do 2 and 24. No, we couldn't do 2 and 24. That won't work. We could do 2 and 21. 2 and 21 work. Absolutely. We could also just do 6 and 7. Right? Any of those numbers. I'm just gonna do 6 and 7. Those seem like the easiest, but it doesn't matter. Javen, that's okay. That's all right. So let's do 6 and 7. Again, 7 I can't break down. It's 6, 7. Ah. 7 I can't break down at all, right? So let's break down 6 into 2 and 3. Okay. So if I want to know the least common multiple of both of these numbers, here's how I do it. The way to kind of think about this least common multiple is I want a number that I would be able to divide by 75, meaning I would want it to be able, well, let me even write this out because this might not be clear to everybody. This means another way of writing the number 75 is 3 times 5 times 5. Y'all, give me a letter Y in chat if that makes sense. If I multiply 3 times 5 times 5, definitely has to be 75. Similarly with 42, if I multiply 2 times 3 times 7, again, that has to be 42. And this is a way of thinking about like the numbers broken down into the like smallest possible pieces that we can break them down into. So I need a number that when I divide by all of this, it will definitely divide evenly into it. And when I divide by all of this, it'll definitely divide evenly into it. And so first I'll think, in order for something to be divisible by 75, well, yeah, I just got to divide by, I need to have 1, 3, and 2 5s in my number in order to be able to divide this by 75. Right? Everybody give me a Y in chat if that makes sense. I just need to have all these numbers in it, or I won't be able to divide it by 75. It won't be a multiple if I don't do that. But also, I also need to have all of these numbers in my multiple as well. In order to be able to divide by 42, I'm going to have all those numbers. Now, here's the thing though. I already got a 3. Right? When I put these numbers in, I already got a 3, so I'm covered there. What are just the only two other numbers I have to have in my multiple in order to be able to divide by 42? Well, here's the thing. I got to have a 2, right? because I need to have a 2 to be able to divide by 42, and I gotta have a 7 in order to also be able to divide by 42. Exactly. So y'all, give me a Y in chat if that makes sense. I don't have to put another 3 in here because I already got the 3. I already got it. So I don't need to have 2 3s. Neither of my numbers need 2 3s. So I just need 2 times 3 times 5 times 5 times 7. Again, let's do this. And this would be divisible by both 42 and by 75. Either one would work. And let's do this in the order we want to do it in. Y'all, if you're looking at all these numbers, you can put it into a calculator. But if you're looking at all these numbers, I really like making 10 whenever possible. So I'm going to multiply 2 times 5 first, just to turn that into 10. Y'all, give me a Y in chat if that makes sense. I'm just going to do that first. I kind of like that. And then maybe I'll do 3 times 5, turn that into 15, because 10 times 15 doesn't seem so bad. And then I'll just multiply that by 7. So that'll just be the same thing as, I'm going to do this, like 150 times 7. And okay, that's pretty big. That's pretty big, right? What is this going to be? 7 times 100 is 700, and 7 times 50 would be 350. So 700 plus 350 would be 1050. And believe it or not, that would be the least common multiple. Man, this doesn't look like it was going to be that bad. But if we tried to write all those out, oh my goodness, that would be crazy. But if we just think about what the numbers are made of, and we just make sure all of those numbers are in our multiple, then we got it. All right, that was a little bit more of an advanced concept. Give me a Y in chat if it at least kind of made sense. It's okay if it didn't completely make sense. This was kind of more of an advanced idea. But I just wanted to show it to you in case they throw something like that at you. Usually it'll be more like this, where the numbers aren't that bad. You could actually just kind of write them out. But if you're ever unsure if they look really janky, try this factor tree thing. Let's see if that works. Okay, so I do have 2 problems for y'all. It's not exactly about that concept, but it's kind of more, like I said, these are kind of throwbacks to the ratio ones that you did in number sense part 1. Because in number sense part 1, you talked about ratios, you talked about percents. This is pretty similar. So if you did number sense part 1, you might be in a good place for this. If you didn't do number sense part 1, don't worry about it, because we're going to talk it through. And I'm going to try and make it intuitive. But the poll is up on the screen if you want to vote. A fruit juice container holds 16 servings. If the serving size is 6 ounces, is another way that you could think about it. 6 ounces per every serving. And like basically we're just saying for every single one of these 16 servings, every single one of them is going to give us 6 ounces. So if I have 16 of these, I have to have 16 sixes, right? So like for like serving number 1, I have to have 6 ounces, and serving number 2, I have to have 6 ounces, and serving number 3, I have to have 6 ounces, etc., etc., etc. So y'all, give me a Y in chat if that makes sense. And yeah, Mahabriam, that is how we're really going to do it. We're not really going to add 16 sixes together, but I just wanted just to have that intuition that that's what we're really doing. We're just saying, oh my goodness, I have 16 sixes that I have to add together. But of course, that is just what multiplication means. That is just what it means to multiply, so we can do 6 times 16. Now let me give you, you'll put this into a calculator, but let me give you a little way of doing mental math in case you're interested. This is, you might have actually seen me do this on the last problem, but like another way to do like multiplication with 2-digit numbers is we can also write this as 6 times 10 plus 6. Y'all, give me a Y in chat if that makes sense, that those are just the same thing. Cool, cool, cool. And then when you get to algebra, you will talk a lot about this thing called distribution. which basically just means if I have like addition or subtraction in parentheses, I can multiply by that. I just gotta multiply, make sure I multiply both pieces. And if you practice this, you can get good at it and do it in your head. 6 times 10 is 60, and 6 times 6 is 36. So instead of like, doing like the kind of normal multiplication where we like carry the whatever, which I always hate it. I guess it's not that bad in this case to do it the good old traditional way. But I would say like most of the time, I really do my multiplication like this because it's just maybe a little bit easier to do it mentally, at least for me. Very good, Candida. Awesome. And like almost all of us in the poll. Got that right. Very, very good. Y'all know your rates. You know your ratios. Let's try one more with the same idea. This is also like a rate type problem. Let me clear the poll for y'all. At a certain store, loose leaf paper comes only in packages of 400 sheets. If a student buys enough packages at this store to fill 3 binders with 150 sheets of paper each, how many sheets will be left over? I'm sorry to say for this poor boy, um, he's gonna have a lot left over. he's gonna wish they came in smaller packages. But let's first just figure out how many sheets he's gonna need, y'all. And this is the same thing we just did with the like ounces. If it's 150 sheets of paper each, and there's gonna be 3 of them, y'all, how many sheets of paper does he need? Yes, Kaya, you got it. Definitely more than 400. So he's not going to get away with just one package. He's not going to be able to do just one package. Unfortunately, one package is just barely not going to make it because 3 times 150, or you could think of it as 150 plus 150 plus 150 because he needs to do 3 binders, each with 150 pages. But of course, we probably wouldn't do it that way. We just do it with the multiplication. And we can, again, do the distribution if you want. 100 plus 50. And just say that's 300 plus 150 or 450. All right, so one package is not going to be enough. He's not going to make it to 450, meaning he has to buy 2 packages. So, like, how many pieces of paper total is he going to have when he does that? Oh, this always sucks to have happen. Yes, Debbie. Yes, Tyrese. He is going to have 800 pieces of paper. We want to know how many are left over. Well, y'all, that's always going to be subtraction. That is always going to mean subtraction. So we have 800. We're going to get rid of the 450 in the binders. And shaga boom. We got it. 850 minus 450 will be 350. Or answer choice C. Dakshash, you got it. But very good, y'all. And so the main idea here, if you had any discomfort with this or you weren't sure how to answer this, definitely go back to number sense part 1. I guess we're probably not doing it again for a while if we just did it on Saturday. So I would say go to the video. Again, the videos for all the sessions are, if you just scroll down in your CapTest account, just scroll down and you should see them split up by like the different sections, GED sections, and click on the one you want, click on math, and then it'll show like all the videos. And those videos will also be in the order that you're supposed to attend them as well. So like you're supposed to do number sense 1 first, then number sense 2, then algebra 1, then algebra 2. So just kind of look out for that, y'all, for your future math sessions. But that is all I got for y'all tonight. Really, really great job, everybody.